In the year 2000, it was announced that we had developed the first draft of the human genome, which is a blueprint for making human life. The human proteome is the next project that we are undertaking.
Biology and medicine are terribly complicated, and you have to use holistic, global approaches. And those approaches lead us to pioneer new types of technologies, and then we apply these to fundamental problems in biology and more recently in medicine. Proteomics is important because proteins are the molecular engines of life. So we have to understand proteins if we're to understand biology.
There are about 20,000 different proteins in our body, and understanding the functions of all of those proteins is the main goal of the Human Proteome Project.
The challenges with the analysis of human proteins are that it must be done by a technique called mass spectrometry, wherein you cut the proteins into smaller fragments that are called peptides, and you actually analyze the peptides. You had 20,000 proteins, each of which is cut into 50 peptides. It is an enormous computational problem.
We're able to now access many more proteins than what we could see in the past. That gave us large amounts of data, then they all needed to be catalogued. With all of this information, we'll be able to interrogate the human and trying to understand what's going on before a disease starts.
We have a compute cluster here at ISB that allows us to keep up with new data sets, but we benefit from processing all of the older data that's been generated over and over again with newer software and newer reference proteome, and that takes more computational capacity than we have.
Sometimes somebody have a big project, they need to run their job, so I cannot utilize all cores. For Azure, now I have 2,400 cores. It's about 5 times more cores than we locally have. It's easy to understand the Azure sample code and modify it to fit my need.
Now that we've assembled all of these mass spectrometry data sets gathered from all around the world into the Azure storage system, the research community can bring their own algorithms and their own insights and apply it to those data residing already in Azure. The impact of understanding the function of all of these proteins will help us understand and treat rare genetic disorders, as well as treat Alzheimer's and type 1 diabetes that we still don't have effective treatments for.